Okay, we already looked into two. It's just like, okay, we already looked into two techniques, which is direct mapping and also block direct mapping. Now we have another one. Why we always have another solution? It is like we improving ourselves, improving any kind of things in these worlds. Let's say you can see we have uh iPhone 11, and then we have iPhone 12, and then after this we're going to see iPhone 13. Maybe somehow it's going to be like iPhone 20 and so on. So we improve from one to another. So sometimes, although we are improving, we still can like having some disadvantages. So we will improve again disadvantages with another version. So how we improve it, the disadvantages, we use different technique. Maybe we put another different pixels of camera. This is technique also, it's called as a technique. So same goes to whatever we are playing around. Now we are looking into the cage, and how we apply it, how we implement our contents, our words in the cache, in also our main memory. We have several techniques. So in a fully associative mapping, you can see that it's try to overcome. So this is the objective, which is you try to overcome disadvantages that give by your direct mapping. How this fully associated mapping overcome the advantages of direct mapping is by permitting each main memory block to be loaded into any locations, which is line, slot, or block of the cache. So this is how also I give you the example when you move from iPhone 11 to iPhone 12. So it try to, let's say, I don't know, I didn't use iPhone. So maybe iPhone 11 have zoom only 30 times, but because of these disadvantages, you want to zoom until ultra, which is 100 times. Okay, so you will use a different camera maybe. So this is the technique, or this is the way how you solve the problem at iPhone 11. Same goes to the fully associated mapping. You try to solve the direct mapping problem, which is disadvantages, by using new terms or methods or algorithms. So over here in our fully associated mapping, it's using the permissions each memory block to be loaded in any location. So what is this? Basically, if we look the example, then we can see it more clearly. So same goes to direct mapping, and then our block direct mapping. We can see there is a format. The format of the addresses. Same goes to the fully associate mapping. It has their own format. So over here, this is the format for the main memory. So for the cache, later on you will see how it's going to look like. So for the main memory address, you're going to have the tag and also the words. So how many of these is depend on also the questions. Let's take a look. Okay, this part we already looked into the early techniques, which is direct mapping. Same goes to the example and also the exercise I give. You will see that when you have the mesh found, you're going to have the cache hit. But if let's say your tag, if your tag previously is 10, and now when you want to update from your main memory, the tag is 11. So you can see the tag in your cache is 10. So it is not same. So you need to update with new. So when it's not same, it is a cache miss. Okay, so basically it's similar also. So let's take a look into the example. So you were given with the questions like this. Consider a memory configuration with to the power of 14, and you know this is 14 bits altogether of your memory configurations. So let's say you were having the tag and also words, right? This is the format for your main memory under your fully associative mapping. So like this. And all together, you were given the hint. The first hint is it is 14 bits. And you read back, you have the cache of 16 block. How the cache will be look like as a 16 block. So in the fully associative mapping, you don't know yet how the cache memory will be look like. But later on we will see. It's okay. One by one. Now the next you can see block of 8 words. This is another keyword which mean 8 words. Words is having 8 words. So it is to the power of 3. So how many bits? It is 3 bits. And of course, you know this is 14 bits altogether will be 11 bits for your text, and your words will be 3 bits. It's easy, right? How to get the text and also the words. And that's why you can see you have the word is 3 bits and your text size is 11. Then you will come out with these solutions. So later on, you will see about the block. How are you going to draw the block for your cache memory? Okay, before that, if you look a previous example in your block direct message, you can see that if your addresses given in the question, let's say I give you example, okay, just randomly. Let's say you have the memory address of 100 hexadecimal. And if you convert it to the binary address, maybe you will get 1111100, let's say. And you have the total memory configuration is 10 bits. So this one is an example that I just created. I don't know whether it's correct or not. Okay, so you have 10 bits and you were given with the memory address. When you convert to binary, you will get 11111100. So this is only 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. But you need to have full bits of 10. So what you need to do is you need to put extra 00 in front. Okay, so you need to have extra 00 in front, which is your answer now for your address will be 0011111100. This is because you want to complete it to be 10 bits if the question given is 10 bits for your memory. So that is the example. That's why after this you're going to see, you're going to add 00 in front. This one also you already looked into previous example. Okay, now let's say you were given this similar like your previous question, which is you have a total of 14 bits and your word is 3 bits and your text 11 bits. And how about your words? So another example, if you have 3 bits, you're going to have 8 blocks. 8 blocks of your words. So you can see over here, to the power of 3, you have 8 possibility. You have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, until 1, 1, 1. All together is 8 block of your words. If the question, you have 2 words, 2 bits of your words. You have 2 bits, and what you're going to have is, you're going to have, ignore this first. I want to teach you about the words. Okay, you're going to have like this: 0, 0, 0, 1, 1, 0, 1, 1. This is for your words. If you have to the power of 2 equal to 4 blocks altogether. If, again, you have 4 bits, let's say you have 4 bits, of course you're going to have to the power of 4 is equal to 16 blocks. So you're going to have, it's of course it's going to be long. And over here you have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, and etc. until you have 16 blocks of your words. Okay, this is example if you have different kind of bits for your words. Okay, that is about that. And now, for this question, you can see you were given for the memory address 666 hexadecimal. You try to convert it to the binary, you will get, I don't know, I just follow the answer given. You will get 0, 1, 1, 0. Basically, sometimes it's not showing the 0 in front. You will get 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. And of course, over here, it will be like putting every byte and byte. So of course, I already mentioned it's a 4 bit, 4 bit, 4 bits. So 1 byte, 1 byte, 1 byte. And you can see you only have 12 if you direct convert from this 6666 hexadecimal. And your question asking you to have 14. That's why you need to add another 0, 0 in front for your total up 14 bits. Now you have this one. This is for your main memory. For your main memory, and you will see that 3 bit is for your words. So you will put 1, 1, 0. And for your tag, it will be 0, 0, 1, 1, 0, 1, 1, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it correct or not? 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0. 4, 8, 9, 10, 11. Okay, 11. And over here, it will be 1, 1, 0. So this is the format for you for the main memory address. Basically, it is similar. And this one, you're going to see this tag. You're going to put into your cache. This is your tag. And this value, you convert from this binary to hexadecimal and put it into the cache memory just to update. And what you're going to see over here, you have 8 blocks. What you're going to find is only the words. Sam goes to your memory is 110. That's why you will find any content inside your 110 value. Like previously you have the table, right? Content. So if let's say you have the cache memory of 0cch and then your words is 110. So what is the content inside this? Because you have basically many, but for the equation over here for 6666H, you're going to look on into one only, which is 110 value. Let's say over here is FF. So this is the content that you need to update to your cache. Okay. Next is the example. If over here you were given with the memory address, you need to find out the cache memory tag. But now you were given with the vice versa, which is you were given with the tag value, you were given with the words value. You need to find out the memory address. If you look, this is playing around with your mathematics subject. When you have let's say you have x equal y plus z minus 10 maybe, so you need to find x, but maybe the value of x is given, you need to find out z. So what you need to do is you need to have like 10x minus y. So it is just play around with the equation. So in this question, you are given with total up 14 bits for your memory. So of course, your main memory will be having 14 bits. Okay, this is the first clue, first hint, first keywords. And you have the blocks of your words is 8. When you have 8 blocks, you have 3 bits. So your words is 3 bits. And the rest will be 11 bits for your tag. Okay, this is the hint that you get. Now, the next hint is give you the cache memory. The cache memory for the tag. Tag cache memory, and you have the words 101. So we fill in this first. Fill in over here. Where should I write? Okay lah, over here lah, maybe tag. This one is main memory and words. 3 bits, 11 bits. So I have over here 101. I put 101. Then finish. I just left it first. Now the tag, I have 256. For the tag over here is 256. I just convert this tag to binary. When I convert 256 to binary, I will get 0110 1010 010. Okay, I will get like this, but it is only 10. It is only 10, and I need to have another. Is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it 11? So I have 4, 4, 4, 4, 4, 3, 4, 8, 11, 12, 13. 8, 9, 10, 11, 11. So I have 11 altogether. You can see over here I have 11 for my tag. This is how I directly convert this 256 to be in terms of the binary. When I have this, which is total up as 11, I guess this one is no need to put first because we need only 11 bits. Then this one is our word is 3 bits. So all together is 14 bits. Now from here, you're going to see you will get altogether the value of this one. And what you're going to get is when you convert it into the hexadecimal, you will get your memory address. You're not going to put this cache behind. You need to put it in front. And your cache and your words is behind. So this is from your words and this is from your tag. And you combine it all together and you convert it into your hexadecimal, you will get the memory address. Vice versa, if you have the memory address, you're going to change it into your binary. These 3 bit at behind will be your words and this rest will be your 256. So you just play around vice versa, you will get the answer. So it is not too hard. So of course, your fully associative mapping having the disadvantages and the advantages. So the advantages is flexibility, and for disadvantages is expensive. So you can go through why it's expensive, why it is flexible. Again, if you can always hurt me, I always said that yeah, of course everything's have something that can be improved. Same goes to ourselves. Maybe we said I'm too perfect already, I'm the best person in this world, but there is none like that. So whatever you need to think, although me itself, we have something that lack. Maybe you don't know, maybe you didn't realize, or maybe you realize but you just like too egos to accept it. So there will always a room to improve. Maybe you can always heard about this previously. There will be always there will always be a room to improve. So same goes to the techniques. So when you have this one, the fully associative mapping, you still have another way. Maybe there is another gap, maybe a niche that is a very small niche, but still you still have a room to improve. Sam got a fully associative mapping. Now you have something that you can try to come up with, which is called as set associative mapping. And you can see over here, this set associative mapping is combinations of advantages between direct mapping and your fully associative mapping. So as I mentioned, maybe if you cannot like just solve the problem from the fully associative mapping, you can like combine with another things and so on. This is same goes to your final year project later on. If you have a PSM, maybe you have the technique A and technique B. If you just apply existing technique, it's called as applied sign, which is you apply existing technique, existing work into your project. But when you are like you apply A, but you combine, you did something improvement, something that you are the one that do it, which is your own not achievement, your contributions. You integrate A and B, it's going to be come out, although it is two existing method A and B, but you come out with C. C is a combination between A and B. It is not yet applied. So you already come out with one new technique. So same goes to this one. Set associative mapping. It is a new technique which is combinations of strengths or the advantages of direct mapping and fully associative mapping. The rest you can read by yourself. Okay. If you look, as I mentioned also, you have every standard, every technique have their own standard, their own format. Same goes to the associative set associative mapping. You can see it's totally like a similar, but you have in between there is a set. Now previously if you see you only have a tag and also words. Now you need something between, is called as a set. If you have a long as a 14, previously you can just divide it into words and also tag. But now you need to divide between tag, set and words. Okay, you have several ways. Later on you will see 2 ways, 4 ways, and then another one is 8. And what is 2 ways of your set associative mapping? You're going to see over here how you're going to draw your cache memory table. Okay, this question you were given with 14 bytes. You were going to give it 14 bytes to the power of 14 bytes. And of course, this is 14 bits all together for your main memory. Okay, so this is 14 bits all together. And because it's 14 bits, what else? First of all, maybe you were not given with this kind of things. You were given with the explanations or maybe the hints or sentences about the question. It is mapped to 2-way, which is set associative cache having 16 block. Then you're going to see your cache table will be having 16 block. I don't know what it's supposed to be look like. Maybe it's going to be like this until 16. Maybe it's going to be like 8 and then you have 2, one top and one down is going to be until 16 block. So how? Okay. So this is the question marks that you need to ask yourself also. If this is the first time you are looking with the 2-way of your set associative mapping. And where each block contain 8 words. 2-way, you can see each block contains 8 words. So means that you have 2-way, which is 1 and 2, and then you have 8. 1, 2, 3, 4 until 8. So you have 8 over here and you have 2, 1, 2, and all together will be 16 block. Am I correct? So you have 16 block. This is for your cache. See? This is for your cache. Since it is a 2-way cache,
it's 16 hours.
Each set consists of 2 blocks. So, you can see? Because it's 2-way cache, it is 2 block. 1 block, 2 block. And all of it have the 8 words. 1 word, 2 words, 3 words, 4 words until 8. This one is also similar and all together you get 16 blocks. They are 8 sets. Because basically it's already mentioned on the top. So it is just like explanations. Why? Because you are using the 2-way cache. Those, because of this, you can see, because you have 8 words. 8 words is to the power of 3. So for your words, you will have 3 bits. Now you come out with 3 bits for your words. for your 8 set over here, for your 8 set, see over here, for your 8 set, you're going to have to the power of 3 also. That's why you get 3 bits. And of course, the rest, if it's not mentioned, also the leftover, you will know it is for your tag. Okay, so this is two-way. If let's say it give you over here 4 words, okay, if let's say it's 4 words and you have 16 block, you have two-way. Of course, you're going to have, I guess, multiple time, 2 block, because it's two-way, 2 block, and you have 4 words. So how many longs that you're going to have just to fulfill your words and also set? Later on you will see. So now you can see over here, you're going to have like a set of, this one is 4 words, and you have a set of 8. This one is 8. Adds word and also add set. And let's take a look. This is how your cache memory will look like, because you have two way. You have 2 blocks. And you're going to have 8. 1, 2, 3, 4, 5, 6, 7. All together is 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 is going to be 16 block all together. And how many set that you will have? It's already mentioned you're going to have 8 set, because you have 2 block. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is how I draw. And if let's say over here, this one you were given, okay, in the question, you were given, but you need to know 3 bits, 3 bits, 8 bits over here. If you don't know this one, you cannot separate your value. This is for your hexa, and you convert it into binary. So you will get this value, and until down. And for the first line, let's say you have first line, you have the tag of 7. Words. So you put here words. Your set is also 7. Your tag, if you convert it, you're going to get FF. Is it correct or not? Okay, so this is for the first line. Second line, you have, this is as a 6. Your set is similar, which is 7. And you're going to have the value of FF. So let's take a look at the answer. See? And you're going to move. Second, you're going to have 4, 5. 5 for your words. And for your set is similar, 7. Your tag is also similar, FF. And this one is 4, FF. So you will get like this. And followed by every single line. One you have done over here, you're going to continue also. But you can see now it's a group different set. So it's going to be 4, 5, 6, 6. 6 for the tag. And this value of the addresses were given, okay? You are the one that need to change this into binary, and you need to know the how many bits for the word set and also tag. And now that is for your two-way. If you have four-way and you have the same blocks, amounts of block, you have the same amount of your memory. Let's say you have 16. Okay. Kat mana I nak draw? So you have four-way, means that you have 4 blocks. 1, 2, 3, 4. I have 4 blocks. And of course, if I have 4, I need to times with 4 as to get 16, right? So I have 1, 2, 3, 4. So all together, I will get 16. I have, why I have 4 block? Because it is 4-way. And why I have 4 set? Because of I need to have 4 only to get it as 16. 4 times 4 will get 16. That's why I have 4 set. I have 4 words over here inside. I have 4 blocks inside because it is 4-way. And the words is given already. It is to the power of 3. See over here? Okay, I explain it back. So you can see, let's say you were given the example previously for 2 ways. For 2 ways over here, you were given the similar, which is 14 bits. You were given 16 block. 16 block, but 2-way, you're going to have only 2 blocks. 1 and 2. This is 2 block. And how many set that you need to have? You need to have 8 set. 8 times 2, you're going to get 16. If let's say you are using 2-way, 2 blocks, and you need to have like 16 also. Maybe something that I can calculate to 8 to 4. Okay, let's say I have only how many set that I need. Let's say I want to have altogether 16 times 2, or maybe I put it over here 8. Okay, I have 2 over here. How many set are supposedly to have for the 2 blocks? So I need to have 4 set of my set is a 4, and for my 2-way is 2 block. Altogether I will get 2 blocks. So this is my set. My set over here is to the power of 2. So it is 2 bits for my set. And the words is depend on the words. If let's say over here is 2 the power of 3, it is 3. So 3, 2, and the rest will be 9, I guess. Suppose blah, 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 blah. Okay, 9. So this is my tag. So this is example. And for 4-way, you need to have 4 blocks. 4-way, you need to have 4 blocks. Because it's 4 block, so you need to know how many blocks altogether. It is 16. 4 times 4 is get a 16 altogether. So your set will have the 4 set to the power of 2. Now your bits for your set is 2 only. You read over here, your words is to the power of 3. So it is 3 bits and altogether will be tagged for 9 bits. Okay, this is very simple, I guess, for you. Only that you need to know if it is 4-way, you have 4 blocks, 2-way, you have 2 blocks, and how you're going to justify it. You're going to get, let's say I have another one, purple block for maybe I have 24, let's say. I have altogether 24 blocks, and I'm using 4-way. So how many set I have? 6 set, right? So I need to have 6 set altogether. Of course, I don't have to the power of what over here. So it's cannot, maybe I have 32. 32 block. So I have 8 at set. So that's why I'm going to have 3 bits and my set now is 3 bits. It depends on the question. Of course, it's going to give you direct. it's not going like you need to find out what is to the power of what over here, because maybe if let's say like this 24, I cannot get the value, so it's very hard. So that's why it's going to be give you a direct. Now how it's going to be look like? So this one will be the things. So you have 1 block, 2 block, 3 block, 4 block, 1 2 3 4. And same also the value is given. Let's say you were given with addresses of your hexadecimal memory address is 3 FFF. You convert it into binary, you will get like this. And how you're going to separate it is depend on the questions, like these 2 bits and 3 bits. This one is 7, this one is 3, this one is I think FF. So that's why for first line I have my set. My set over here is 3, and then the value of 7, and this is a FF. Second is 4 6 6. My set is 3 again, the value is FF. Third line is 1 is 5. 5, and then set is 3, and I have the FF over here. And next is 100 is 4, 3, and then FFF. Next, you can see this one is 011, it is 3, and the set also is 3, and until the rest. It is not too hard for you to fill in, right? And you have another one, later on you will see the 8th way. But now you can see you have the example, another example. Suppose we want to read or write. Okay, this is under read or write. You can see at the memory address. The value already give. So they already give you their value. Okay, you can see 357A. How and what you need to do first? You need to convert. You convert to binary. And this is the questions that already give you. So altogether is 18 bits. 18 bits, and you need to separate it into 4 bits. This one 6 bits, and then this is another 8 bits. And this value, of course, you need to later on change it into the hexadecimals to put it into your table. So we search only the 2 tags in cache a set, which is 23, because this is for the set, to see either one match with the tag or 16 or not. If Sam is going to be hit. This one is basically similar. Last time we look into the words, now we look into the set. And about the tag, we will update if it is different, it's going to be missed, and if similar, it's going to be hit. Okay, now you were given with the tables. This is direct mapping. One way set associative. So you are there, you have this one table only. If 2, you can see you have 2 blocks, this and this, and altogether the set is depend on how many block you have. If let's say you have 8 blocks, at blocks you're going to have 2 times with 4 set. So you have 4 set of your set. 4 will be to the power of 2 bits. And now you can see you have another one is 4-way. 4-way, you're going to have 4 blocks also. And because it is 8 blocks altogether, you're going to have 2 set. 2 times with 4, it's going to get 8. So 2 to the power of 1 will be 2. So this is 1 bit for your set. And how about this one? 8 way of which is called as a fully associative. This is the one that you learn in your fully associative, which is 8-way set associative. Same. Over here you have 8 blocks. All together is 8 block. And because of this, you don't have set. Why you call as a fully associative? Because if you look over here, you need to have in a set associative, you need to have set, words, and tag. For your two-way associative, you have if let's say it is 8 block, okay, so you have 2 bits. For your 4-way, you have 1 bit, still have a bit. But for 8-way, you have 0 bit, because what, you have one set only, and 1 is to the power of 0 equal to 1. This is 0 bit, so you don't have a set, like you just having the tag and words, because your set is 0. So that's why this also as a fully associative, but only for the 8 block. Kalau if you are having 16 block, it's going to be maybe different way how it's going to be look like until it's 16. Okay, so I guess it is not too hard. So next is our replacement policy when you want to replace. Last time you have hit, miss, right? So let's say you have a tag. You have a tag and then you have the content. So let's say you have 10 and this is for your cache. And for your main memory, you have 11. So if you want to replace, there is a replacement policy. You cannot just directly replace. It's called as a replacement policy. So please make sure you go through how you're going to replace. There are several schemes. For direct mapping, there is no no choice is possible. That's why you can directly replace. It is not too hard for direct mapping and block direct mapping. But fully associative and set associative, you're going to have 4-way for the replacement methods, or it's called as a replacement policy. It's called as first in, first out, or least less recently used, least frequently used, and lastly a random. Okay, so that's why it is all over here, and you can see why what is the use of all this algorithm. Of course, it's going to be cover different kind of operation, different kind of way and step, and etc. So which replacement algorithm is the best? Of course, same goes to you currently in the class. You have about 14 students only in our class. I think 13. So I don't know where is the rest. Another 7 or 8 students, they are missing. But of course, from your 13 students, you should be have the best student among of yourself, among of your class. Same goes to the method. Same goes to algorithm. You're going to have the best. And yeah, you can try to read it, but the one that I'm going to teach, which is after this on the policy, this policy I'm going to come out with one video, and same goes to this one. You need to have the equation. I'm going to cover also, and there is example I'm going to touch, but what I want you to do is to do the exercise. If you don't know how to do the exercise, at least you know how to do the example. in the video, I'm not going to provide the exercise video together with the example, because I want to ask you in the class. Please don't take our time, our precious time, just to wait for you. So next class, okay, tomorrow, if you don't have class, I have class at 8 a.m. until 10 a.m. I'm going to have like a discussion also with the student related to the test 2, upcoming test 2. If you have class, maybe we have a class on Friday. Where is your exam? 11. 11 is what day?
Friday.
Friday.
Friday, yeah.
Or it's Friday. So maybe you have another tomorrow only. Maybe if you have class, you cannot join. Maybe I will share with you the video.
I have class tomorrow, Victoria.
Okay, it's okay. I will give you the video, video of our discussion, or maybe I will give you also what topic or subtopic, or which pages that you need to like give full attention most, especially for your test 2. Because I guess because it is too near for your test 2, so I hope that all of you already done with the what you need to do. You need to do exercise. You need to read back and go through all the 3 and 4, isn't it, for your test 2. So all of that you need to have finished to do the revision. So for tomorrow, for the video and for the hint, it's just for you last minute study, which is the one that you can focus most, because you're done with the revision. So maybe you can focus most which part that I will share later on. So that is about next things. So this one, this exercise, we're going to do in our next class. So please be prepared with your laptop, and then you need to like teach us. I'm not using the words of explain, but you need to teach us. Teach in terms of your own understanding. So this one is not too hard. So we nearly to finish our module 6. Later on, we have another last, which is 6.4. This one is a very small part, only a few pages left. So it is not too hard, I guess. So I think only that. So you have another about 30 minutes for those who still did not understand for the question 6.1. You can try to do until you understand how to stop sharing. Okay. And maybe you can have this time for do the revision. So I hope that you already finished doing the revision. Don't do last minute. And I will share with all of you in the WhatsApp group any update. If let's say I have update with the video, and also I will like writing up which pages, which part that you need to focus most for your test 2. Is it okay?
Okay, doctor.
Okay,
Okay.
doctor.
So is there any question related what we